Hello everyone, and welcome back to the channel. Today, we're diving into a fundamental concept in networking, inter-VLAN routing. Specifically, we'll be setting up what's known as router on a stick using Cisco Packet Tracer. This method is incredibly efficient because it allows different VLANs to communicate with each other using just a single physical interface on a router. By the end of this tutorial, you will have a solid understanding of how it works and be able to configure it yourself. First things first, let's talk about why we even need this. Imagine you have a company with different departments, like sales and IT. For security and organizational reasons, you've put them on separate VLANs. That's great for keeping their traffic isolated. But what happens when someone from sales needs to access a server in the IT department? By default, they can't. The traffic is stuck within its own VLAN. Inter-VLAN routing is the solution that bridges this gap, acting like a traffic cop directing data between these separate virtual networks. So, let's get our hands dirty in Packet Tracer. We're going to build a simple yet effective network topology. We'll need one router use a 2911 model. We'll also need one switch a 2960 will do just fine. And finally, we'll add the PCs to our workspace. We'll connect the PCs to the sales VLAN and the other two to the IT VLAN. Let's start by physically connecting our devices. Use a copper straight-through cable to connect the PCs to the switch. I'll connect PC 0 to fast Ethernet 0 over 1 and PC 1 to fast Ethernet 0 halves. These will be our sales machines. Then, I'll connect PC 2 to fast Ethernet 0 thirds and PC 3 to fast Ethernet 0 quarters for our IT department. Finally, we need to connect our switch to our router. Grab another straight-through cable and connect the switch as Gigabit Ethernet 0 over 1 port to the router as Gigabit Ethernet 00's port. It is a good practice to use the gigabit ports for the trunk link between the switch and router to handle the combined traffic from all VLANs. Alright, our physical topology is set up. Now, let's move on to the fun part, the configuration. We'll start with the switch. Click on the switch. Go to the CLI tab, and let's get started. First, we enter privileged exec mode by typing enable. Then, we go into global configuration mode with the command configure terminal. Our first task on the switch is to create our VLANs. We'll create two, one for sales and one for IT. The commands are super straightforward. To create the sales VLAN, we'll type VLAN 10. The number 10 is the VLAN ID. It can be any number you choose, but it's good to keep them organized. After creating the VLAN, we can give it a name to make it easier to identify. Let's name it Sales with the command name Sales. Now, we'll do the same for the IT department. We'll create VLAN 20 by typing VLAN 20, and then we'll name it IT with the command name IT. You can verify that your VLANs were created by typing do show VLAN brief. The do command lets you run exec level commands from configuration mode. You should see VLAN 10 named Sales and VLAN 20 named IT in the list. Perfect. Now that our VLANs exist, we need to assign our switch ports to them. At this point, if you try to ping from a sales PC to an IT PC, it will fail. They are completely isolated, and that's exactly what we want for now. The next crucial step is to configure the link between our switch and our router. This link needs to carry traffic for both VLAN 10 and VLAN 20. A port that can carry traffic for multiple VLANs is called a trunk port. We connected our switch's Gigabit Ethernet 0 over 1 port to the router. So let's configure it. We'll enter the interface configuration with interface Gigabit Ethernet 01. This tells the switch that this interface is responsible for passing traffic from all allowed VLANs to the router. By default, a trunk port allows all VLANs, which is fine for our setup. With that command, our switch is fully configured for router on a stick. Now, let's shift our focus to the router. This is where the inter-VLAN part of the routing really happens. Here's the core concept of router on a stick. We're going to create virtual subinterfaces on this single physical interface. Each subinterface will act as the default gateway for one of our VLANs. Let's start with the sales VLAN, which is VLAN 10. To create a subinterface for it, the command is interface gigabit Ethernet 0010. The number after the dot, in this case 10, is just a subinterface identifier. It's a best practice to match it with the VLAN ID to avoid confusion. So we'll use 10 for VLAN 10. The second thing we need to do is assign an IP address. This IP address will serve as the default gateway for all the devices in VLAN 10. Let us define our IP scheme. We'll use the 192.168, 10.0 network for sales and 192.168, 20.0 for IT. So, for the sales gateway, let's assign the first usable IP address. The command will be IP address 192.168. 10.1 followed by the subnet mask to 55.255.255.0. That's it for the sales VLAN subinterface. Now we just need to repeat the process for the IT VLAN. Let's exit and create the subinterface for VLAN 20 with the command interface gigabit Ethernet 0020. Then we'll assign its IP address, which will be the gateway for the IT network. We'll use IP address 192.168, 20.1 with the same subnet mask to 55.255.255.0. Our router configuration is now complete. We've set up 2 virtual subinterfaces, each acting as a gateway for one of our VLANs. The final step is to configure the IP addresses on our PCs, so they can actually use these gateways. Let's go to our first sales PC, PC0. Click on it. Go to the Desktop tab, and then IP configuration. .255.0, and most importantly, the default gateway to the router's subinterface address, which is 192.168, 10.1. Let's do the same for the other sales PC, PC1. We'll give it the IP 192.168, 10.11, same subnet mask, and the same default gateway, 192.168, 10.1. Now for the IT PCs. On PC2, we'll set the IP to 192.168, 20.1, and its default gateway will be the one we configured for the IT VLAN, which is 192.168, 20.1. And finally, for PC3, we'll use IP 192.168, 20.11, with the same gateway of 192.168, 21. Everything is configured. It's time to test our setup. Let's start by testing connectivity within the same VLAN. Open the command prompt on PC0 and try to ping PC1 at 192.168. 10.11. The ping should be successful. This confirms our VLAN configuration on the switch is working correctly. Now for the real test. Inter-VLAN communication. From the same PC in the sales VLAN. Let's try to ping a PC in the IT VLAN. Say PC2 at 192.168. 20.1. The first packet might time out while the ERP process resolves the MAC addresses, but the subsequent pings should be successful. And there you have it. We have successfully configured router on a stick. Let's trace the path of that ping to understand what just happened. So, it sent the packet to its default gateway, which is the router subinterface 192.168. 10.1. The switch received the frame, saw it was destined for the router on its trunk port, and forwarded it with the VLAN 10 tag. The router received the tagged frame, knew it belonged to the gigabit 0010 subinterface, and de-encapsulated it. The router then looked at its routing table, saw the destination 192.168. 20.1 was directly connected via its gigabit 0020 subinterface, and re-encapsulated the packet with a VLAN 20 tag. It sent this tagged frame back down the trunk link to the switch. The switch received the frame tagged for VLAN 20 and knew it could only forward it out of ports belonging to VLAN 20. It sent the frame to PC2, and the ping was successful. This process happens in reverse for the reply. That's the magic of router on a stick. So, to recap, we designed our topology, created VLANs on the switch, assigned ports to those VLANs, configured a trunk port to connect to the router, and then on the router, we created a subinterface for each VLAN, assigned encapsulation, and an IP address to act as the gateway. It's a very elegant and scalable solution for small to medium-sized networks. I hope this step-by-step guide was clear and helpful. Practice is key, so I encourage you to build this topology yourself in Packet Tracer and experiment with it. Maybe add a third VLAN or a server. The more you practice, the more these concepts will stick. Thanks so much for watching. If you found this video useful, please give it a thumbs up. And don't forget to subscribe for more networking tutorials. Let me know in the comments if you have any questions. See you in the next one.